Hi dear students, welcome to Brilliant Group of Institution. Here we have the chapter Hydrocarbons from the grade 11, one of the most important organic chapter, Hydrocarbons. We are going to discuss the complete chapter, most important question, most important in the sense most type, the almost all repeated naming reactions, conversion questions, reasoning questions, almost all type of question we are going to discuss in this video. It will be so helpful for your upcoming school examination, I'm sure about it. So dear all, the hydrocarbon, I hope you have a general idea about the organic chemistry, nomenclature and everything. Here we are going to discuss so many reactions, and let me classify the chapter into four important parts: alkane, alkene, alkyne and aromatic compound like a benzene. So from all four chapter, most important reaction we will discuss once again. Okay, so through questions I will discuss the theory of the chapter and most important reactions in detail. All of you be ready for the questions. Okay, question number first one from alkane portion. So first area we are making into alkane. Okay, only alkane all reactions we are going to prepare. You may study the alkane. Let me just recap all the things you studied in this chapter. Alkanes, alkane general formula, everything is a saturated compound. Alkanes, how many preparations you have studied? You may studied alkynes and alkenes, like unsaturated compound to which if you add hydrogen in presence of nickel, platinum, palladium catalyst, it may converted toward alkane, right? Means unsaturated compound to which if you add hydrogen, it become alkane, correct? Second reaction you may studied from haloalkane or alkyl halide. Just treat with the hydrogen in presence of zinc and an acid, you will get a alkane. And one more reaction you may studied from haloalkane itself, that is called Wood's reaction, one of the most sure question for your exam. Wood's reaction you may study. And the fourth and fifth method is from sodium salt of carboxylic acid. One is called decarboxylation, one is called Kolb's electrolysis. So let me tell you the question from that particular, these five reactions, alkane, this five preparation, from which how they can ask question. Dear all, carefully listen. First question, how will you convert propene to propane? A simple question. Okay, we are starting the chapter with a simple question. How will you convert? So first question, how will you convert propene? What is propene, right? This is called the propene, right? Propene. How you can convert it into propane? How you can convert it into propane? Those who are not understanding about the conversion questions, try to understand here all. Whenever you get a question for conversion, write the reactant and product first. Okay, then you check what is the difference between them or what is the change happen. See, the double bond becomes single bond. Double bond, if you want to make it single bond in a hydrocarbon, what is the reaction? Hydrogenation, right? So let me add hydrogen in presence of nickel, platinum or palladium catalyst. What is the process called? Hydrogenation. Addition of hydrogen we call hydrogenation. What is the point here? Unsaturated compound, which means double and triple bond, you can make into a saturated alkane by the addition of hydrogen with the nickel, platinum, palladium catalyst. Is it clear all of you? Right. So this is the method. Second one, 1-chloroethane. What is 1-chloroethane? CH3CH2Cl. This is 1-chloroethane. Am I right? This one you have to convert it into what? Alkane without any change in number of carbon. You see 2 carbon here, 2 carbon here. If you want to change a haloalkane, is it a haloalkane? Yes. If you want to convert a haloalkane into an alkane without changing the number of carbon, then you have to do just add hydrogen in presence of zinc and an acid. This is also actually hydrogenation. We are adding hydrogen. But on unsaturated compound, if you want to make into saturated, add hydrogen with this catalyst. If you want to convert a haloalkane into an alkane, add hydrogen with what? Zinc and acid. Okay. So this is the first two reactions, first two preparation based questions. Okay. The next reaction, as I told you, Wood's reaction, that is also from haloalkane. Woods reaction, dear all, one of the most sure question for your exam, Woods reaction. What do you mean by Woods reaction? They ask you the statement. How you can answer the Woods reaction, all of you memorize or understand. Woods reaction is a reaction between two haloalkane. Normally we are using two same haloalkane. What happen if we use two different haloalkane? You may know that. Anyway, we can discuss. So Woods reaction is a combination, or it's mixing of two haloalkane with what? Sodium. So dear all, take two haloalkane. Take two haloalkane, react with the sodium in which medium? Dry ether medium. You will get an alkane. So what is that alkane speciality? All of you try to understand. This alkane always contain even numbered carbon. Even numbered. Always during Woods reaction, if you are mixing two same haloalkane with the sodium in dry ether, you will get an alkane. Always it contain even number of carbon, means two carbon. For example, you can prepare ethane. You can prepare butane, you can prepare hexane, you can prepare octane, like even numbered you can prepare. Then which all alkane you can't prepare through Woods reaction? Odd numbered. Which all are odd number? Methane. Right? Propane, methane, propane, pentane, heptane. These odd numbered alkane we can prepare through Woods reaction. So dear all, once again, once you finish this video, you should able to answer, or you should memorize, you should able to recap all these reactions once again. Okay, like that, please watch this video. So Woods reaction is a combination of two haloalkane with a sodium, with a metallic sodium in dry ether, give you an alkane with an even numbered carbon. Okay, odd numbered alkane we can prepare through this method. This is what we call Woods reaction. With an example, okay, take a haloalkane. For example, CH3Cl. What is the name of this haloalkane? Methyl chloride or chloromethane. Always, whenever you're doing Woods reaction, two same species select. Okay, so two haloalkane with the two sodium. I'm not just going to try to balance the reaction, dear all. I'm just saying what is the reaction. Okay, so why and in presence of what? Dry ether. Why we are taking two sodium here? You know that these two sodium take this two chlorine. This 2 sodium take this 2 chlorine. So what eliminate? 2 NaCl get eliminated. What is left in the system? 2 CH3 group is there, right? So CH3 combined with another CH3, what you will get? Ethane. Have you noticed that, dear all? Ethane, how many carbon? 2 carbon. Even number, right? Yes. What is this compound? Chloromethane, right? Chloromethane contain 1 carbon, but your product contain 2 carbon. So there is actually a doubling of carbon. So dear all, Woods reaction in which there is a doubling of carbon happen. If you start with a meth, your product is eth. If you start with the eth, your product is but. If you start with a prop, your product is hexane, like that. Okay, so this is about Woods reaction. Not over. Next question. What happens when chloromethane react with the chloroethane? Here is the one I said. Here we are going to, this is actually a question. I'm just making clear. I'm just adding one point here. What happens when chloromethane react with the chloroethane in Woods reaction? Okay, means reacting with the sodium. Okay, so chloromethane is one haloalkane, chloroethane is another haloalkane, right? What is chloromethane? CH3Cl. What is chloroethane? CH3, CH2Cl. They are treating with the what? Sodium in what medium? Dry ether medium. Correct? Now the question, if it undergo Woods reaction, what happened? Just in the previous question we said that when you're doing a Woods reaction, always we have to select two same haloalkane. But what happened? It's a demerit, all of you. What happened if you take a one compound with another different haloalkane? Consider as this is compound A, this is compound B. What we are expecting, this methyl and this ethyl, just clap, what you will get? Propane. Yes, we will get propane, correct. We will get propane, yes, plus. What is this? Propane. But you can ask a question, sir, we discussed in the previous topic, we can't able to prepare odd numbered alkane, right? Yeah, this is propane odd number. Then why you said it's always giving even number? Dear all, this is one of the product when methanamine react with, the methyl chloride react with the ethyl chloride. There is some more products can form because this A can combine with another A. How another A? Dear all, chloromethane is a solution, right? Chloromethane is one of the molecule. In a solution, many chloromethane will be there. So, one chloromethane combined with another chloromethane, then what will happen? This CH3 and this CH3 will join. You will get ethane. Ethane plus, why plus? There is one more product. How it is? This is B. This is chloroethane. In its own solution, there will be many chloroethane. So, it can combine with another chloromethane. It can combine with another chloromethane. Can you guess it? What is the product? This ethyl combined with this ethyl. What you get, dear all? Butane. You will get butane. So, dear all, generally, if you mix two same haloalkane, there is only one chance. You will get only one product in good yield. But if you take one haloalkane with another haloalkane during Woods reaction, you will get majority 3 product. Mixture of products will get it. Then you can ask a question, it's a merit, right? We are getting lot of products. It's not a merit, dear all, it's a demerit. Why? Because in this reaction, if you are getting 3 products, they all are forming in the same mixture, means the same beaker. Can you able to separate it out? It's a solution, dear all. So, all these 3 are in the same beaker, mean you can't able to separate it out, right? This a separation makes difficult. So, this is that's why we are mixing haloalkane. The 2 same haloalkanes we are trying to mix during which one? Woods reaction. Hope it's clear what is clearly Woods reaction and the demerit. And one more question you can expect from Woods reaction, all of you. Identify the haloalkane from which hexane can be prepared. What is hexane? You know, this is hexane, right? This is hexane. Hexane is an alkane. By Woods reaction, you know, Woods reaction mean we are treating with sodium, right? 2 sodium will be there. The medium, you know, dry ether is there. All right. What is the haloalkane? Very simple question, dear all. Here they given the product and they asking the reactant. Very simple in Woods reaction. What you have to do then? Cut the center part of the alkane. Which is the center part of the alkane? This one. Overall hex, right? You know, 1/2 from one haloalkane, other half from other haloalkane. That's it. So, you just add. You can take any halogen. Okay, chlorine. It's not compulsory. It should be chlorine. Bromine is also fine. So, let me take, add one chlorine here and chlorine here. What is the compound? CH3, CH2, CH2, Cl. That is the haloalkane. CH3, CH2, CH2, Cl. Right? So, this haloalkane we have to take 2 times. So, what happened? This propyl combined with another propyl, you will get this hexane. So, let me ask you another question. In order to prepare this alkane, what is the name of this alkane? 2,3-dimethyl-butane. Through Woods reaction, which haloalkane can be selected? Can you tell me, dear all? Procedure is same. Cut the double bond. the middle part. Cut the middle part and add one chlorine on this carbon and on this carbon. So, what is the product, dear all? CH3, CH, Cl, CH3. This is the compound. Okay, like 2 compound, take 2 sodium and dry ether. So, what is the name of this compound? You know, 1, 2, 3, 2 chloropropane. 2 chloropropane. Like that, they will ask you the questions like, what is Woods reaction? What is the demerit of Woods reaction? And this, which one? They give you the product from which reactant we can prepare this. These are the type of question you can expect from Woods reaction. Clear all of you? Clear all of you? Okay, listen. Next, 4th preparation we said from carboxylic acid. Carboxylic acid, in which 2 methods are there: decarboxylation and Kolb's electrolysis. First one, what is decarboxylation? Meaning of decarboxylation, you know, removal of carbon dioxide, correct? What is decarboxylation in reaction? How can we say? Dear all, note it. Sodium salt of carboxylic acid Okay, sodium salt of any carboxylic acid. For example, sodium salt of ethanoic acid is called sodium ethanoate. Sodium salt of propanoic acid is called sodium propanoate. Sodium salt of butanoic acid is called sodium butanoate. So any sodium salt of carboxylic acid you take, treat with what? Soda lime. You may study what is soda lime. Dear all, soda lime is a mixture of NaOH and CaO. Good, carry out. What is its preparation? You know, decarboxylation is a preparation of alkane, dear all, and byproduct mostly it will be Na2CO3. Keep in mind all of you, byproduct will be Na2CO3. And so this is actually, if they ask, define decarboxylation, you can select this. So how you can define decarboxylation? Sodium salt of any carboxylic acid treated with a soda lime, we get an alkane with the byproduct Na2CO3 is called decarboxylation. What is the speciality of this reaction? It's an alkane. Yes, no doubt it's a formation of alkane. What is the speciality in this one? Dear all, if your carboxylic acid, suppose it contains 3 carbon, your alkane contains 2 carbon. So what is the speciality of decarboxylation? You will get an alkane with 1 carbon atom less than the reactant. If you start with a sodium propanoate, your product will be ethane. If you start with a sodium butanoate, your product will be propane. Means 1 carbon less product you will get it. This is called what? Decarboxylation. And how they ask the next question from decarboxylation, let's see. That's why I told you here we are discussing all important reaction and the maximum types of question. Okay, see that. Identify the carboxylic acid from which butane can be prepared by decarboxylation. So first you should think decarboxylation. Okay, decarboxylation means product contain 1 carbon less than the reactant. Correct. The alkane is already given here, butane, right? What is butane? CH3, CH2, CH2, CH3, butane. If I want to get butane, what sodium salt, which sodium salt of acid I want to choose? Here 1 carbon high, 1 carbon less. This is but, so what it should be? Pent. So what we can write? CH3, CH2, 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 COOH, right? This is what? Pentanoic acid. But you know, decarboxylation not starting with acid. Decarboxylation starting with what? Sodium salt of acid. So what can we do there? It's how you can make it with sodium salt, treat with NaOH. Treat with what? NaOH. What happened when acid combined with the base? You know, that water eliminate, right? So what you will get? CH3, CH2, 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 COO, Na. You will get sodium salt of pentanoic acid. It's also called sodium pentanoate. So dear all, in order to get butane through decarboxylation, sodium salt of which acid can be used? Sodium pentanoate. If let me ask a question. If you want to prepare propane, if you want to prepare propane through decarboxylation, sodium salt of which acid you prefer? Can you tell me? You may select sodium salt of, if you want to get propane, we will use what? Sodium salt of butanoic acid. That is called sodium butanoate. Am I right? And they ask you the opposite. Like if you start with a sodium pentanoate, which alkane you can prepare? Butane. Clear all of you? So study what is decarboxylation, what is the change in number of carbon and this type of question. And we have one more preparation of alkane from sodium salt of acid. Which one is there? Kolb's electrolysis, right? Listen all of you. Explain Kolb's electrolysis reaction. What is that? Here we are taking sodium or potassium salt. Sodium salt of a carboxylic acid. We are mixing in water, means we are taking an aqueous solution of the salt acid and we are passing electricity. So electricity means most of the chapter this reaction will be Kolb's electrolysis. Okay, electricity. So what we did here, aqueous solution of sodium salt of a carboxylic acid and to which what we are passing? Electricity. Dear all, let me tell you a shortcut method. Okay, it's a shortcut method. Total there are 4 products. How many products in that decarboxylation? Decarboxylation, you will get an alkane. Do you remember the byproduct in decarboxylation? Na2CO3, always. But in Kolb's electrolysis, total there are 4 things. Among these, 3 of them are the byproducts. That byproduct, let me tell you first. They are NaOH, carbon dioxide, and hydrogen. This is almost common in all reaction. So it's easy. NaOH. In Kolb's reaction, Kolb's electrolysis, NaOH, carbon dioxide, hydrogen. These are the byproduct. How to remember which alkane can form? That is only one very simple method, let me tell you. Okay, here we can generally say a alkane is the preparation. So what is Kolb's reaction? How can we say, dear, or how you explain what is Kolb's reaction? When an aqueous solution of a sodium salt of a carboxylic acid, through which if you pass electricity, it forms an alkane with this byproducts, is called Kolb's electrolysis. What is the example? Let's discuss with an example. For example, CH3COONA plus H2O and passing electricity. Can you say the name of this sodium salt, dear all? You know, this is sodium salt of 2 carbon, ethanoic acid, right? So what is called sodium ethanoate? Sodium ethanoate. You know, ethanoic acid is also called acetic acid. So it's also known as what? Sodium acetate. Clear about the name, all of you? Sodium ethanoate or sodium acetate. Dear all, if it is decarboxylation, what you do there? If it is decarboxylation, this is eth, so you will write a product here, methane, correct? If it is Kolb's electrolysis, let me give a shortcut method. If it is Kolb's electrolysis, byproduct is common, NaOH, CO2, H2, that you write it. How to write the main product? The alkyl group, they are all in the sodium salt of acid, which is the alkyl group, this one, right? The alkyl group double. The alkyl group double. Okay, so CH3 double means what it become? CH3 single bond CH3. You will get ethane. You start with the sodium ethanoate, but product is what? Ethane. So in Kolb's reaction, keep in mind, all of you, which is the alkyl group that you double. Okay, here the alkyl group is CH3, the double. If it is CH3, CH2, it's double, butane, like that. So this is the difference between Kolb's and the decarboxylation reaction. Clear, all of you? So 5 preparations of alkanes are there. One is hydrogenation to an unsaturated compound, it becomes saturated. Second method is from haloalkane, by treating with the hydrogen with zinc and acid, you will get alkene. Third one, Wood's reaction, that is also from haloalkane. Fourth is from sodium salt of carboxylic acid, either you can perform decarboxylation or you can perform Kolb's electrolysis. These are the 5 reactions we have for converting or preparing alkanes. Okay, so these alkane preparation part, these are the main type of question you can expect here. Next one, you may studied another topic, that physical property of alkane. After preparing alkane, we have to study the property, right? First one, alkanes, you know, boiling point related questions are sure one for your exam. Keep in mind. Boiling point mainly depends on molecular mass. Okay, molecular mass. Molecular mass is directly proportional to boiling point. Means whenever you get a 2-3 compound, first you want to check it their molecular mass. Which one having greatest mass, they having greatest boiling point. Okay, first factor you analyze that. Okay, second one, this is first factor. Okay, second one. Suppose you have 2 compounds with the same mass, then what to do? Suppose if you have 2 compounds with the same mass, they are called isomer, right? Same molecular formula, they are called isomer. In isomer, check the number of branch. Okay, number of branch. You know, number of branches when increases. Number of branches when increases, surface area decreases. Therefore, boiling point decreases. So, number of branch is inversely proportional to what? Boiling point. Let me discuss with an example. Carefully notice all. Arrange the following in increasing order of boiling point. Let me draw the structure of each compound. 2-methyl butane, right? Let me draw very fast. 2-methyl butane. This is first compound. Okay. Second one, N-pentane. What is N-pentane? Normal pentane, right? 5 carbon. Normal pentane. Third one, neopentane. What is neopentane? 1 carbon connected to 4 methyl group. 1 carbon connected to 4 methyl group is called neopentane or 2,2-dimethyl propane. And the fourth one is normal hexane. Normal hexane means how many carbon? There will be 6 carbon, right? Normal hexane means there will be 6 carbon. Tell me all of you, which one you think the highest boiling point? Which one of the following having highest boiling point? First go to mass, don't go to branch. Which one having the greatest mass, the greatest number of carbon and all? It's having 5 carbon, 5 carbon, 5 carbon. This is 6 carbon. This is the one with the high mass. No doubt, fourth one is the highest boiling point. So fourth one, let me cut. I think 1, 2, 3 are isomers. 1, 2, 3 are isomer because they have same number of carbon, same number of hydrogen, etc. In that case only you should check about the branch. Where there is more branch, where less boiling point. So you can able to see second compound, no branch, right? Second compound, no branch. So high boiling point. So second. Okay. 1 and 3, where is more branch? Third one, right? Where least boiling point. So 3 and 1. Okay. So hexane having greatest because of high mass. Then second one because pentane in which there is no branch. And this one having 1 branch, this one having 2 branch. Okay. So 4, 2, 1, 3. 4, 2, 1, 3. Clear all of you? This is about the question type you can expect from boiling point area. Okay. So remember the points. Next one, how will you convert methane to ethane? Let me ask a question. How will you convert methane to ethane? Think about it. Methane. What is methane? CH4. Correct? What is ethane? CH3 single bond CH3. So think about it here all. Someone able to answer the conversion question so fast as someone has to think. So carefully listen. Methane to ethane. What is the procedure? Here actually 1 carbon we need to increase extra. Correct? 1 carbon we need to increase extra. 1 carbon increase if you want or we want to double the number of carbon mean we studied Woods reaction. Correct. Woods reaction there is a doubling of carbon. But in Woods reaction we studied but in Woods reaction we can prepare an alkane, even numbered alkane. Yes, it's an even numbered alkane. But you know Woods reaction starting from haloalkane. Woods reaction starting from haloalkane. It's not haloalkane, it's alkane, right? It's an alkane, right? But you may studied one another reaction, substitution reaction in this chapter. What do you mean by substitution? To an alkane, when you add halogen, for example chlorine, in presence of light or heat, what is this reaction called? Substitution reaction. What do you mean by substitution? To an alkane, when you add halogen in presence of light, what happened? 1 H, 1 Cl gone as HCl. What is remaining? CH3Cl. Have you noticed dear all? Now we are getting haloalkane. So if you want to convert an alkane to haloalkane, just add chlorine in presence of what? Light. You got CH3Cl. Now you perform Woods reaction. What is Woods reaction? Take its 2 haloalkane, mix with the 2 sodium. In which medium dear all? Dry ether. The 2 sodium take this 2 chlorine. What eliminate? 2 NaCl eliminate. The CH3 get twice. Yes, we will get ethane. So dear all, first methane on substitution, you will get chloromethane. Chloromethane on Woods reaction, you will get ethane. This way you have to perform the studied experiment into the reactions. Okay, hope it's clear. Next one. Explain aromatization reaction. What do you mean by aromatization? One of the most direct question for your exam. Study only these 2 examples basically for your exam. What do you mean by aromatization? You know, meaning of aromatization is formation of aromatic compound like benzene. Okay, let me take one of the example which is given in your textbook, that is hexane. Hexane is mentioned in this way. Why we are explaining in this way? You know, hexane mean we can write it a straight manner, right? This is normally what? Normal hexane only. That's normal hexane, no branches and all. Dear all, when you pass hexane through, hope you remember the three reagents we are using here. Cr2O3, V2O5 or MO2O3, molybdenum. Chromium, vanadium, molybdenum. It's oxide. Cr2O3 or V2O5 or MO2O3 at 773 Kelvin and 10 to 20 atm pressure. If you do this process, what happens, dear all? The first carbon and the sixth carbon get joined and it become alternate double bond come inside. We are not studying the mechanism, only the reaction. So hexane, when react with this reagent, you will get an aromatic compound that is nothing but benzene. In the same question, you can explain another way. How will you convert hexane to benzene? That is what? The aromatization. So here what is happening? A not aromatic compound converted to aromatic. That is called aromatization reaction. There is one, if you read NCERT textbook, just below this question, the reaction, they given as a question, what happened when N-heptane react with this reagent, or when it undergo aromatization, what happened? Let me write N-heptane like this, okay? Hexane case we discuss. Now I am writing heptane case, heptane, okay? This is what? N-heptane. Same reagent, suppose if you use when it undergo aromatization, can you guess the product, dear all? Anyway, we need to get benzene because benzene is aromatic, okay? So, okay, this is CH2, right? This carbon and this carbon, same like this. This second and sixth carbon just join, you will get benzene. What is extra here? One CH3 extra. What is that benzene with the CH3 we call? Yes, it's called known as what? Toluene. This is it. So remember, dear all, how you can explain what is aromatization? When hexane react with these reagents at 773 Kelvin and 10 to 20 atm pressure, it gives benzene. If you start with a heptane, you will get what? Toluene. This is called what? Aromatization, and one of the example, formation of aromatic compound like benzene. Okay, next one. What happens when methane? What is methane? CH4. All right. What happened when methane undergo complete combustion? What do you mean by complete combustion? It's reacting completely with oxygen. You know that any hydrocarbon when undergo complete combustion, what we get? Carbon dioxide and water. Any hydrocarbon on complete combustion, what we get? Carbon dioxide and water. I am not balancing here, you know that. I am just saying the reaction. Second one, what happened methane undergo incomplete combustion? If there is no sufficient or the availability of oxygen, if it undergo incomplete combustion, what you will get? Instead of carbon dioxide, you will get carbon and H2O. Remember, complete combustion means carbon dioxide and water. Incomplete combustion means carbon and water. Okay. And third one, what happened when methane react with the steam? What is steam means? H2O, vapor. Steam, right? H2O, heating. What happened methane when generally heating with which one? Water. Normally it's explained in presence of catalyst. If you heat it will give you carbon monoxide and hydrogen. So keep in mind all of you, hydrocarbon on complete combustion we will get carbon dioxide and water. Incomplete combustion you will get carbon and water. When it's react with the steam, we will get carbon monoxide and hydrogen gas. Okay, this reaction keep in mind. Next one, explain pyrolysis with an example. You may study it. Pyrolysis is also known as what? Cracking process, right? Cracking process. What do you mean by pyrolysis? A big hydrocarbon, a long hydrocarbon chain, a alkane chain. Once you heat it, normally if you heat with have you seen that here oxygen not there? If you heat with the oxygen, it may convert it to carbon dioxide and water, starting with the hexane. This is only one example given in textbook. Hexane. Hexane is what? C6H14. When hexane heated with oxygen, it may undergo combustion. It gives you carbon dioxide and water. But it is absence of oxygen. It's a heating at a very high temperature around 773. A big hydrocarbons breaks to small alkanes and alkenes are known as pyrolysis or cracking. How can you define what is pyrolysis? A long hydrocarbon chain breaks to small alkanes and alkenes are known as what? The pyrolysis process. Study this example here all. Hexane, when heated at 773 Kelvin, it can break in three ways. One is, maybe it will give you hexene with hydrogen. What is this compound here all? Maybe it will give you, this is what? Hexene with hydrogen. What is C4H8? Butene. What is C2H6? That is ethane. Or it can give C3H6. What is C3H6? Propene. What is C2H4? Ethene. And what is CH4? Methane. These ways it can break. Generally, a big hydrocarbon breaks to small alkanes and alkenes is known as what? The process what we call cracking or pyrolysis. Clear all of you? Now I am discussing one of the most important area from the chapter. You may study one of the special isomerism given by alkanes, that is called conformation isomerism or conformers, right? What are conformations or what are conformation isomerism? Dear all, it is different arrangements. You know, isomer means same molecular formula but different arrangement, right? Conformation isomerism is given by alkanes, which is formed by the free rotation of carbon-carbon sigma bond. Okay. So once again I am repeating, what is the definition of conformation isomerism or conformers? They are this generally exhibited by alkanes. Why alkenes and alkynes do not exhibit conformation mean they contain pi bond. Pi bond can't be what? It's not rotatable. Only sigma bond is rotatable. So why conformations, right? Conformations happens due to the free rotation of atoms around carbon-carbon sigma bond and gives different spatial arrangements called which one? Conformation isomerism. You may study it in detail about the conformation isomerism of which one? Ethane molecule, Sohor's eclipse representation. They ask you to draw the diagram, dear all. Very important. Listen. So study the definition here. What is conformation isomerism and or what are conformations? Then draw the Sohor's and Newman projections for eclipsed and staggered form of which one? Ethane. Okay. You know what is ethane? Ethane means CH3, single bond CH3. We can express like CH3, normal, okay? CH3. You can able to see here, there is a carbon-carbon sigma bond. This bond you can rotate. If you rotate that bond, different spatial arrangements are getting. Okay, let's discuss in detail. Carefully listen how to draw it. Let me take the first carbon. I'm going for the Sohor's representation first. Okay, Sohor's. As per Sohor's, the carbon-carbon bond represented like this, just like an inclined line. On the first carbon, you can able to see there are three hydrogens, right? Let me place one hydrogen, second hydrogen, third hydrogen with a 120 bond angle. Even the other carbon also carry three hydrogen, this hydrogen. Have you noticed that when you analyze this structure, these all are face to face, right? These all are. This is the first carbon with the three hydrogen. This is the second carbon with three hydrogen. They are face to face. It is highly unstable because of repulsion. Same groups repel. If they are face to face, same group repel. That is called torsional strain. So this form is called what? Eclipsed form. Eclipsed is the highly unstable conformation isomerism. Okay. Eclipsed means all are face to face. How to do staggered one? Staggered one, same this one. They're all first carbon, don't change it. Okay. First carbon as it is. First carbon as it is, draw the three hydrogen. The other hydrogen rotate the other three hydrogens rotate 180 degree. If you rotate 180 degree, it will come down, right? So this hydrogen, this side and all come to the opposite. So initially you have all are face to face, that is called eclipse. Now you rotated, keeping the front carbon as it is, you rotated the back carbon 180 degree. Now all are opposite. This is called what? Most stable conformation and it is called staggered form. Staggered form. Okay, staggered. This is eclipse, this is staggered. Which is most stable? Staggered, right? Because of less torsional strain. Due to less torsional strain, and here due to more torsional strain it is highly unstable. Now what is torsional strain in the sense I told you know that repulsion. Now only these two structures are possible for ethane? No, between eclipsed and staggered many are there, what they call it as skew form. Between eclipsed and staggered many forms are called skew form. So what about one more scientist given explanation? What is that? Newman representation. As per Newman, first carbon he expressed with a dot in which we have 3 hydrogen. Okay. And the back carbon, second carbon he expressed by a circle in which 3 hydrogens are there. If they are face to face, which form is this? This is the eclipsed form in Newman. What about the staggered? The front carbon he expressed by a dot in which 3 hydrogens are there. The back carbon he expressed by a circle in which 3 hydrogens are far away, and this is the most, see there is no repulsion and all, very free. This is called which form? Staggered form. So they will ask you to draw the eclipsed and staggered form for Sohors and Newman, and they ask you the stability order also. Dear all, they will ask you explain the stability order of conformations of ethane. What is the order we can able to say? Staggered is the most stable one, then skew forms, then we have eclipsed form. Why staggered is most stable, dear all? Due to less torsional strain. Why eclipsed is more unstable? Because of more torsional strain. So clear about this. They will ask you to draw any one of Sohors or Newman for eclipsed and staggered. Okay, study and the which one? It's the stability order also. Clear all of you? Now some questions. Complete the reactions. Okay, so overall alkane part, which all let me just conclude. Sodium butanoate. Can you say what is sodium butanoate? That is CH3CH2 CH2COONA, right? Sodium salt of butanoic acid is called sodium butanoate. React with the soda lime. Come on, dear all. What is soda lime? NaOH and CaO. Can you tell me which reaction is this? Yes, it is decarboxylation. In decarboxylation, what will happen? In decarboxylation, you know, your reactant contain 4 carbon, so your product contain 3 carbon, 1 carbon less. So what we will get? Propane, right? Propane. Hope you remember the byproduct in decarboxylation is Na2CO3, right? So product is propane. Correct. Next. Ethane, second reaction. What is ethane? CH3CH3. Ethane react with chlorine in presence of sunlight. What is this reaction? Addition of halogen in presence of light. Substitution reaction. What to do in substitution? Take one H, take one Cl, HCl eliminate, put chlorine inside. You will get CH3, CH2, Cl along with HCl. You will get chloroethane. What about next one? Passing electricity. Passing electricity through, electricity means which one? Kolb's electrolysis, right? Aqueous solution of sodium acetate. What is sodium acetate? CH3COONA. Sodium ethanoate is also called sodium acetate. Aqueous solution, so mix with the water and passing electricity. Passing electricity. What happened here all? Hope you remember the 3 byproduct in Kolb's reaction. Which all are they? NaOH is there, carbon dioxide is there, hydrogen is there. How many of you remember how to remember the product in Kolb's reaction, or how to write? The alkyl group double. So CH3 single bond CH3, right? Its mechanism all are there in the textbook. So CH3 get twice. It become ethane. So this is the way you have to study the chapter. Take important reaction. What all type of question you can expect from that? These are the most type of question you can expect from alkane part. After completing alkane session, we are going for the next most important area, that is alkene. So alkene preparation and all we'll study through the preparation. Let's start. You may study mainly for preparation of alkenes, right? For preparation of alkene, you may study it first from alkyne. To an alkyne, if you add hydrogen, definitely it become what? Alkene, correct? So question. Before that, the isomerism let us discuss. You know the isomerism given by alkenes are cis and trans. Draw the geometrical isomer. What is geometrical isomer? Cis-trans isomerism, correct? Draw the cis-trans isomer of butadiene. What is butadiene? CH3, CH double bond, CH single bond, CH3. This is called butadiene. Dear all, if they ask you to draw cis and trans, draw immediately cis trans and C double bond C 2 2. C double bond C 2 2. This thing you place immediately if they ask you to draw cis and trans. Okay. Which is these two double bonded carbon here? These are the double bonded carbon. On the left carbon, what all species are there? One H, one CH3. What about on right carbon? Same, one H and CH3. If the same group come on same side, what we call cis. It's not compulsory, these two should same, these two should, okay, one of them should be the same and they should be on the same side. How to draw trans? Trans means, cis means same group on same side, trans means same group on opposite side. So place one position as it is, H and CH3, other interchange. So it becomes CH3, HC, they are opposite. This is cis, this is trans. Question, explain its boiling point and melting point. One of the most sure question, listen carefully. You may study dear all. This is cis isomer, hope you clear how to draw it. You know this is an alkyl group. Alkyl groups are electron donating group. Alkyl, all alkyl groups are electron donating group. So they will donate electron in this way. You may study the dipole moment. This is also an electron donating group. So they will donate in this direction. Correct? So both alkyl groups are giving this way. So resultant is upward. There is a resultant or not? Yes. If there is a resultant dipole moment, so it's having a high dipole moment. Cis isomers generally cis isomers having high dipole moment, so high polarity. Higher the dipole moment and higher the polarity means high boiling point. So conclusion, let me tell you all, generally all cis alkenes having high boiling point because they have high dipole moment. All of you just to take trans case. In trans case, this alkyl group donate, this alkyl group donate, they got cancelled, right? Dipole moment will be 0. Not all cases, most of the cases. Anyway, cis isomers having high dipole moment than this one. Okay, so less dipole moment. Less dipole moment. Therefore, what we can say? Low boiling point. So conclusion dear all, cis isomers having high boiling point due to high dipole moment, trans having less boiling point due to less dipole moment. Boiling point clear. What about melting point? Opposite. Melting point high for trans. High melting point. Here in the case of cis isomer, low melting point. What is the reason for melting point? What is the reason for boiling point? Especially dipole moment, polarity and all. But what is the reason for melting point? Symmetry. Symmetry. What do you mean by symmetry? I will just check all of you. In trans isomer, the main groups, they are all are in the same line. See that there is a symmetrical arrangement. But here it is not. If you take all this, all the main groups, so the bulky groups and all are in the, not in the same. If you take symmetry, not like this, okay, not like this. When you're taking a plane, most of the groups should come in the same one, belongs to the plane. This having high symmetry, those having high symmetry, their melting point is higher. So conclusion, study all of you how to draw cis and trans isomer. One question. Second question, they will ask you which one having high boiling point and melting point. Okay, boiling point mainly related to dipole moment. Dipole moment or most of the cases cis having greatest. So cis having high boiling point, but trans having high melting point. But melting point related to which factor? Their symmetry. Symmetry is higher for trans, so it's having high melting point. Overall, cis isomers having high boiling point and low melting point. Melting point, high boiling point, low melting point. But trans having low boiling point and high melting point. Okay, just study from this area. One another question. Which of the following compound will show cis-trans isomerism? Dear all, there are many cases where it can't able to show it. So carefully listen. Let me draw this alkene first, okay? You can able to see that C double bond C. So C double bond C. Can you say what all groups on this carbon? 2 CH3, right? Let me place it. This is one CH3, another CH3. What on right carbon? One H and C2H5. C2H5. Second compound, let me draw C double bond C. Both side, here two side hydrogen, here two side chlorine. Third question, C double bond C, hydrogen, CH3, CH3 chlorine. Okay. What about this last one, C double bond C, chlorine, hydrogen, hydrogen, hydrogen. Which one can able to show a cis-trans isomerism? Tell me the answer, dear all. You may get it. Option A, not possible, because there is no common group in both of the carbon. See, the double bonded carbon, at least one group should be common. Here on one carbon, two groups are similar. That's not enough. So, one condition what? On both of the double bonded carbon, at least one group should be common. It's not there. B option is correct. Why? Because here also the same thing, on the double bonded carbon, there is no common group. On one carbon, two common groups are there. That's not enough. Option C, yes, it is the answer, because here you see CH3 are opposite. We don't need to bother about other, okay? At least one group should be similar. If it is opposite, you know, this is called trans. If you switch this, you will get cis also. Cis and trans do not occur in same structure. This is trans. Yes, there is a cis also. What about this case? Dear all, it cannot. You may think, sir, this hydrogen are same side, right? So this is cis, right? No, but so I can able to say these hydrogen are opposite, right? Trans also no, cis and trans do not occur in same one. So the point is, if any three groups are out of these four group, any three groups are similar, it do not show cis-trans isomerism. Okay, so cis-trans isomerism is given by this compound. Hope it's clear how to draw and the boiling point and all. Now come to our reaction. What happens when but-2-ine? What is but-2-ine? It's an alkyne, right? This is but-2-ine. React with the hydrogens. Of course, it's a hydrogenation reaction, but in presence of two things. One is palladium with charcoal, one is sodium in liquid ammonia. Dear all, first reaction both of the reaction we studied. Generally to an alkyne, when you add hydrogen, that hydrogen go to this carbon and this carbon, it become alkene. That you know. Yes, of course it will happen. But what is these two catalysts? Normally we are using nickel, platinum, palladium. What is this catalyst? Dear all, this is called what? Palladium with charcoal, called palladized charcoal. Palladized charcoal. It's also called what? Lindlar's catalyst. So it's a one mark question for your exam. What is Lindlar's catalyst? Palladized charcoal. Okay, palladized charcoal is called Lindlar's catalyst. And how to get what is the purpose of this Lindlar's catalyst? To produce cis-alkene. To produce cis-alkene. How to get cis-alkene? Where you are going to add this hydrogen? One on this carbon, one on this carbon. Okay, so you will get C double bond C, H, CH3, H, CH3. See, we added that hydrogen on this carbon and it becomes cis-alkene. What is sodium in liquid ammonia? Sodium in liquid ammonium is called a Birch reduction. This is Lindlar's, this is Birch. Lindlar's catalyst will give you always cis-alkene, Birch will give you trans-alkene. Okay, so how to write? One H, one CH3, make CH3 here, H here. We will get trans-alkene. So dear all, generally to an alkyne, when you add hydrogen, it becomes alkene. But if you are using Lindlar's catalyst, it becomes cis-alkene. If you are using Birch one, you will get trans-alkene. That's a difference. Clear all of you? Next one. Explain beta elimination reaction with an example. You know, beta elimination is also known as dehydrohalogenation. dehydrohalogenation. What do you mean by dehydrohalogenation? You know, D, removal of what? One hydrogen and one halogen. We want to remove one hydrogen and halogen. Carefully listen all. Let me discuss with an example. Okay. You consider one haloalkane. It's a chloroethane, right? Dear all, what is the reagent we are using in beta elimination? Remember, alcoholic KOH. What is the reagent we are using in beta elimination? Alcoholic KOH. Keep in mind, okay? So, beta elimination, if it want to happen, there should be a haloalkane and which one? Alcoholic KOH. And what you want to do there? Remove one H, remove one halogen. From where? The rule is there. Halogen you should take from alpha carbon. What is alpha carbon? The main functional group connected carbon is alpha. And hydrogen you should take from beta. What is beta? Alpha carbon connected carbons are called beta. Okay, so always during beta elimination, remove halogen from alpha, remove hydrogen from beta and make a double bond between alpha beta. So let me make a double bond here. What you will get? CH2 double bond CH2, you will get ethene. Okay, this is called beta elimination, dehydrohalogenation. So let me ask you one other question through another reaction. What happened when 2-chlorobutane? Let me draw the structure of that compound. 2-chlorobutane. Right, dear all, this is 2-chlorobutane. When it is react with the alcoholic KOH, what happened? Alcoholic KOH. Alcoholic KOH mean you should think in your mind, this is beta elimination. Beta elimination mean I want to take halogen from alpha carbon. I want to take one hydrogen from where? Beta carbon. Which is beta? I told you alpha carbon connected carbons are beta. There are two beta, they are different. You will get two products. So let me consider, dear all. Let me take halogen from this alpha. Let me take hydrogen from this beta first. Okay. So where I want to make double bond? Here. What you will get? CH2 double bond. CH, CH2, CH3. What we can call for this compound here all? But1ene. If you consider the next hydrogen, take this hydrogen and take this chlorine, you will make double bond here. What you will get? CH3, CH double bond, CH single bond, CH3. You will get but2ene. So conclusion, if we have two beta carbon, they are different, you will get two products. From which is major and minor, we compulsory, we should represent during the reaction. Okay, which is major and minor alkene, that's very important. The major one is, dear all, major one is but2ene. Major one is but2ene, minor one is but1ene. So you may think, sir, according to which rule you are saying this is major and minor? Major and minor we can explain by the help of the rule called Zaitsev rule. Okay, Zaitsev rule. Actually, Zaitsev rule says that. What is where we want to apply Zaitsev rule, dear all? If you get two alkene, which is major alkene and minor alkene, then we are using Zaitsev rule. One more point. According to Zaitsev rule, they are actually saying that more substituted alkenes are major. So you may confuse, what do you mean by more substituted, right? A simple idea, let me tell you. Try to make the double bond in the center part, in the crowded part. That will be the major. What? Actually, according to Zaitsev rule, more substituted alkenes are major product. Okay, but in order to understand easily from which alkene is major, simple, make the double bond maximum at the center part, middle part. That will be the major. See, here it's a middle, almost a crowded part. This is at the end. So this is major, this is minor. This is what we call beta elimination. Reagent what we are using? Alcoholic KOH. Clear? Next. What happens when 1,2-dichloropropane? Let me draw the structure. 1,2-dichloro. Is it correct here all? 1,2-dichloropropane with zinc. You may get the reaction very fast. This is also a preparation of alkene. We may study here all. This is called vicinal dihalide, right? What do you mean by vicinal dihalide? Vicinal dihalide means two halogens are on adjacent carbon. If you treat a vicinal dihalide with a zinc, what happened? That's only study here. Zinc, take this both of the chlorine and eliminate it as ZnCl to zinc chloride. What is remaining? CH3, and there is a double bond comes here. You will get CH3, CH double bond, CH2. You are getting propene. So conclusion, when a vicinal dihalide treated with a zinc, you will get an alkene. Clear all? Next. Write the product formed when ethanol. What is ethanol? CH3, CH2OH. It's a two reaction, okay? One is ethanol, one is propanol. This is ethanol and propanol. What happened when ethanol and propanol treated with, it's a two reaction, okay, not same, with concentrated H2SO4, with a concentrated H2SO4, with a concentrated H2SO4, which means acid. At what temperature? 443 Kelvin. 443 Kelvin. Come on all. Which reaction is this? Can you recollect? Codirol concentrated H2SO4 at 443 mean dehydration. Okay, this is dehydrating agent. Concentrated H2SO4 is a dehydrating agent. What do you mean by dehydration? Removal of water. Dear all, this is alcohol, right? Alcohol from which if you remove water, you will get alkene. Let me show you how to remove water from this one. Do you remember beta elimination? Halogen we will take from alpha. Hydrogen we will take from beta, then you will make a double bond between, right? Same thing, but instead of halogen, here alcohol, that's it. Take alcohol from alpha, take hydrogen from beta. H and OH means water, cut. There is a double bond. You will get ethene. Ethene plus H2O. How you do the same procedure here? So you want to study here, what is concentrated H2SO4 purpose? It's a dehydrating agent. And what to do there? Just cut OH, take from alpha, hydrogen take from beta, make a double bond here. You will get what? Propene. Is it clear all? That's it. So study the reagent function. Acid at a 443 Kelvin mean dehydration. Remove water like this. Clear? Next one. How can you distinguish between propene and propane? Or propene from propane? This is, propene. This is what we call propane, right? This is propene and propane. How can you distinguish these two? It's a unsaturated compound, right? It's an unsaturated. Double bonded and triple bonded compounds are unsaturated, but alkanes are what? Saturated. How can you distinguish between unsaturated compound from saturated? Very simple. Treat with bromine water. What's that? Treat with bromine water. Normally we are adding bromine with CCl4 and all. Okay, bromine water. The bromine water color is a reddish brown. It's having a reddish brown color. Where this, if you add to an alkene bromine, this one bromine goes to this carbon, one bromine goes to this carbon, means double bond, triple bonds are high reactive due to the weak pi bond. So you will get the compound CH3CHBr and then CH2Br. You will get a vicinal dihalide. Means it's reacted or not? Yes. So unsaturated compound can react with the bromine water and it becomes saturated form. The reddish brown color of bromine water changes to what? Colorless. If you notice this color change, a reddish brown color to colorless mean yes, the compound is unsaturated. What about saturated? There is no reaction. There is no color change. It exists as the reddish brown color itself. So what is the test we are using to distinguish between an unsaturated compound from saturated? That is bromine water test. What is the test? Just treat unsaturated compound with a reddish brown bromine water. It become colorless. Clear all? Very good. Next one. State Markovnikov's and Karash effect. Two rules. Most important question from the chapter, Markovnikov's rule and Karash effect. Let me tell you the first one, Markovnikov's rule. Statement, let me tell you with an example. Let me take a alkene here. This is the alkene we call propene. To which suppose let me add a HCl. HCl is known as addendum. Okay. HCl what we call addendum. The adding species we call addendum. That's it. Okay. So to an alkene what we are adding? HCl. HCl is addendum. Addendum contain a positive and negative part, right? It's HCl. We can't use like a Cl2, H2, like such kind of addendum because that doesn't contain positive negative part. Correct. So we can able to add HCl, H2O. What are the ions in H2O? H plus and OH minus. So what is the condition to undergo Markovnikov's rule? The addendum, the adding species must contain positive and negative part. And the alkene should be, the alkene or alkyne possible unsaturated compound, it should be unsymmetrical. And the alkene should be unsymmetrical. Unsymmetrical mean on double bonded carbon, different number of hydrogen should be there. What do you mean by, for example, can we apply ethene for Markovnikov's rule? No, it is a symmetrical alkene because both of the double bonded carbon contain same number of hydrogen. Clear all of you? So what is the first condition to undergo Markovnikov's rule? The alkene or alkyne must be unsymmetrical. Okay. Second one, the addendum should contain positive and negative part, and also it happen in the absence of peroxide. In the absence of peroxide. This is the condition setting. Now let me state what is Markovnikov's rule. Okay. When an addendum contain positive and negative part, when adding to an unsymmetrical alkene or alkyne, the negative part of the addendum, which is the negative part of the addendum, Cl minus, goes to the carbon with less number of hydrogen. You don't need to bother about the saturated carbon. Okay, reaction will take place only on these two carbon. Okay. In these two carbon, this carbon only one hydrogen, this carbon having two hydrogen. So Markovnikov's rule says that negative part goes to carbon with a less hydrogen and positive part goes to carbon with a more number of hydrogen. After the addition, double bond becomes single bond. So what is the product? CH3, CH, Cl, CH3. We'll get 2 chloropropane. This is called Markovnikov's rule. They ask you one another, that is called Karash effect. It is also known as anti-Markovnikov's rule. Anti-Markovnikov's rule, that's a opposite of Markovnikov's rule. It is also known as peroxide effect. Peroxide effect. This is also what called Karash effect. They are all important statement and equations are important. So what is the major difference between Markovnikov's and anti-Markovnikov? Markovnikov happens in the absence of peroxide, but anti-Markovnikov's will happen in the presence of peroxide. Let me take the same example, propene. Same condition, alkene should be unsymmetrical, addendum should contain positive and negative part. Okay, positive and negative part, but it is in the presence of what? Peroxide. Presence of peroxide. Okay, just opposite of Markovnikov's rule. What is that? Negative part of the addendum goes to carbon with a more number of hydrogen and positive part goes to carbon with less number of hydrogen. That is it. That is the Karash effect or anti-Markovnikov's rule. Clear all of you? So statement of Markovnikov and anti-Markovnikov must question. Let me show you one more example. What happens when hex 1 in one of the NCERT question? Let me draw hex 1 in. Okay. CH3, CH2, 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 1, 2, 3, 4, 5. So it will be what? CH double bond CH2. Okay, this is hex 1 in. It is treated with what? They are treating with HBr. Okay, treat with HBr. H plus and Br minus is there in the addendum. In the presence of and absence of peroxide, here all first they are going to add in the presence of peroxide. Presence of peroxide mean which rule can be selected here all? Presence of peroxide mean anti-Markovnikov's rule, right? That we are applying Karash effect. What is Karash effect? Negative part goes to carbon with more number of hydrogen. Positive part goes to less number of hydrogen. Can you tell me the product directly? CH3, CH2, 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 Br. That is called 1-bromohexane. 1 bromohexane. What about if it is in the absence of peroxide? We will follow Markovnikov's rule, right? What is Markovnikov's rule? Negative part. See, all of you, don't be confused. This is anti-Markovnikov's over, Karash over. Markovnikov means negative part goes to carbon with less hydrogen and positive part to more hydrogen. So don't represent all the arrows during examination like this, okay? It will be confusing. So you will get the compound what? 2-bromohexane. 2-bromohexane. So study, okay, just to take the reaction once again and write the reaction. Clear all of you what is Markovnikov's and anti-Markovnikov? Let me give you one more example. Write the reaction of propene with H2O. What is propene? CH3, CH double bond, CH2. This is propene. To which what they are adding? H2O. Think about it. You know, H2O is the adding species, right? H2O contain two ions which all H plus and OH minus. Yes, our addendum contain positive and negative part. The alkene is unsymmetrical. Of course, there is no peroxide given. So of course, what is that? Markovnikov's rule. What is Markovnikov's? Negative part goes to carbon with less, positive part to more. We will get CH3, CH, OH, CH3. You are going to get propan-2-ol. So, to an alkene, when you add water, it becomes alcohol as per Markovnikov's rule. Clear all of you the addition? Hope it's clear. What is the next question? What is Bayer's reagent? What is Bayer's reagent? It's one of the questions. We can able to say cold. Bayer's reagent is cold, dilute, aqueous or alkaline KMnO4 is called Bayer's reagent. So what is Bayer's reagent mean? We can able to say it's a cold and dilute aqueous or alkaline KMnO4, potassium permanganate, is called Bayer's reagent. See how they mention Bayer's reagent. Let me give you a shortcut idea, okay? They give you Bayer's reagent in this way, H2O. Just imagine like this, okay? Shortcut method. Cold and dilute. Dilute means what? H2O, water is there. Plus, dear all, KMnO4 is a very strong oxidizing agent, okay? It will provide oxygen, okay? And writing aqueous KMnO4, aqueous or alkaline. This is the way they give you Bayer's reagent in the question. What is that? H2O. H2O corresponds to what? Cold dilute, okay? Aqueous KMnO4 is a very strong oxidizing agent, that is oxygen, and aqueous KMnO4. Now one more idea, one more trick let me tell you. H2O and O, from which let me take 2 OH group out. Okay? Okay? H2O and O, if you club, don't write H2O2, okay? H2O and O, from which let me take OH and OH. Possible? Just add these 2 OH group on the double bonded carbon. Let me show you. What happened when it react with the propene? What is propene? Propene is CH3, CH double bond, CH2. To which, what they are adding? Bayer's reagent. How they present Bayer's reagent? H2O, O and aqueous KMnO4. Correct. Now, dear all, how to memorize this reaction? Dear all, Bayer's reagent mean it will provide 2 OH group. The 2 OH group, just place it on the double bonded carbon. One on this carbon, one on this carbon, double bond become single bond. So you will get CH3, CH, OH, CH2, OH. Right? We discussed if 2 halogens come on nearest carbon, we call vicinal dihalide. Here 2 OH group on adjacent carbon, we called what? Glycol. Okay, the compound what we call? Glycol. If 2 OH group are present on the adjacent carbon, what we call? Glycol. This is called propane. We can, as a IUPAC name, what we can say? 1, 2, 3, right? We can able to say propane 1,2-diol. Or propane 1,2-diol. It's generally what we call if 2 OH on adjacent carbon, glycol. So study dear all, what is Bayer's reagent? Bayer's reagent is cold, dilute, aqueous or alkaline KMnO4. How they given in the equation? H2O, O and aqueous KMnO4. Just put 2 OH group, place on the double bonded carbon. That's it. This is about Bayer's reagent. Now, the most important reaction from the chapter, from alkene, that is called ozonolysis. You know, it's a 2-step process, right? Write the product formed. Let me explain what is ozonolysis through the reaction. All type of question let's discuss here carefully. First one, A. Hope you can write it. Okay, write in the notebook. Propene. Propene is the alkene. Okay, this is what propene. They will give you an alkene. So, starting of a ozonolysis reaction is what? An alkene. To the alkene, your first step in ozonolysis is adding ozone, O3. How to add this oxygen? Word to add, double bonds if that's the reaction part. First step, dear all, cut the double bond. Cut the double bond. What is left? CH3, CH, CH3. What you have to do in the first step of ozonolysis? To the alkene, add ozone. Okay, cut the double bond. O3 mean 3 oxygen, right? 1 oxygen up, 2 oxygen right down, and make a ring. Just like a house-like structure. This ring structure, we call it as ozonide. Ozonide. The ring structure is always called what? Ozonide. Not over, okay. What is the first step in ozonolysis? To the alkene, add ozone. What is ozone? O3. How to add ozone? Cut the double bond. 1 oxygen up, 2 oxygen down. Second step, it's treating with zinc and H2O. Zinc and H2O. The breaking is this way. Breaking is this way. Break this one. Can you able to see the upper oxygen? This oxygen go with this zinc as ZnO, zinc oxide. Leave it. Our main product is the left and right. What do you have left side? So sorry, I think it is CH2, right, dear all? You may notice that it's CH2, okay? CH2, right? Okay. Now, cut this one. What is the product on left side? CH3, CHO. After breaking, dear all, this carbon and oxygen, don't forget to put a double bond, okay? So, what is the product left side? CH3, CHO. We can write CH3, CHO. What is CH3, CHO is called ethanol. Ethanol plus. What is the product right side? CH2O. What is CH2O? CH2O. 1 carbon, right? I told you after the breaking, the C and O should carry double bond. So, I can write this as HCHO. Check it all of you. HCHO is called methanol. Once again, dear all. Ozonolysis means when an alkene react with the ozone, first it form a ring compound called ozonide. It is broken by the help of zinc and water and produce 2 products. Maybe it is both are aldehyde, maybe both are ketone, maybe 1 aldehyde, 1 ketone. Guaranteed. This is called the what? Ozonolysis reaction. Let me give you some more examples. Already given, only propene is over. Carefully all of you, 2-methyl propene when undergo ozonolysis. Let me just cut this compound. Okay, carefully listen all. B question. 2-methyl propene. What is 2-methyl propene? 2-methyl propene, right? This is 2-methyl propene. What is the first step? Add ozone. What I told you to do that, dear all, cut the double bond. What is, if you cut the double bond? CH2, C, CH3, CH3. This is what left, right? Let me cut the double bond. That is left. And put 1 oxygen up and 2 oxygen down. Just make the ring. This is what we call ozonide. Later, we are going to split this chain by the help of what? Zinc and water. Break these 2 and these 2. Clear all? Tell me what is the product you have left side? This oxygen, no need to worry, okay? This oxygen go with the zinc as zinc oxide, leave it. What is the CH2O? CH2O is nothing but HCHO. What is this compound called? Methanol. Keep practicing by writing the name of the product also, okay? What about the left, right side product? CH3, okay? I'm writing this CH3, single bond. This C and O, I already told you, it will form double bond. And then remaining 1 CH3. What is CH3? CO, CH3 is called, propanone or propan-2-on or acetone. So you may get, sometime you will get both are aldehyde, sometime both are ketone, sometime one aldehyde and one ketone. Let me give you one more example. Don't worry, let's practice maximum. Let me give you one more example, dear all. Carefully listen. 2,3-dimethyl pent-2-ene. Okay. Pent 2,3-dimethyl. See all of you, 2-methyl group. And 2-ene. Second position double bond. Okay. Okay, all. What is first step? You know, first step adding ozone, no doubt. Cut the double bond. Okay, cut the double bond. Make the ring. So CH3, C, CH3, C, CH3, CH2, CH3. After cutting the double bond, you know, we have to place one oxygen up, two oxygen down, make the connection like this. Okay, all, and break it with the help of zinc and water. Make it with the help of zinc and water to these two. Can you say the product which you have on left side? CH3, CO, CH3. CH3, CO, CH3. What we call it as propanone. Propanone plus. What is the product you have on right side? CH3, CO, CH2, CH3. CH3, CO, CH2, CH3. What we call it as butan-2-on. Clear, all of you? This way we can get two products through ozonolysis reaction. This is forward question, right? Here they given the alkene and identify the product after ozonolysis, and they will ask you a reverse question, which means they will give you the product, maybe aldehyde or ketone, and they ask you from which alkene you can make this. Got the question? Check it all. An alkene A undergo ozonolysis, form which all compound? Propan-2-on and ethanol. Identify the compound A, and they will mention in the question through ozonolysis. Okay, don't worry. So propan-2-on, let me give a shortcut method. All of you carefully listen. What is propan-2-on? CH3COCH3. This is called propan-2-on, and ethanol is CH3CHO. This is propan-2-on and this is ethanol. These are the products getting when an alkene undergo ozonolysis. If so, identify the alkene. Okay. So how to do the process, dear all? That is very simple. You write the normal two compound. Any compound they can ask, but method is apply simple, like a simple method. Don't worry. You take the CO group of both of them. Okay. Take the CO group in both of them. Bring close and write down. What? Bring the CO group close, write down. Let me do that. CH3, first compound. CO, I brought closer and write down. The other CH3 right here. This CO, let me bring very close, you know, okay. This CHO, I'll draw like this, and one CH3 is there. So what I did here, bring the CO group close, write down. After that, cut the double bond O part. Cut the double bond O part and place a double bond in between. Finish. What are the three things you did there? Can you repeat? Bring the CO group close, write down, cut the double bond O part and put a double bond in between. So what is the name of the alkene? The alkene is CH3, C, CH3, double bond, CH, CH3. You are going to get 2-methyl but-2-ene. If this alkene undergo ozonolysis, you will get these two products. You can check it. Do ozonolysis on this one. Check it whether you are getting this product or not. Okay. So this way, forward question and the backward question type you can expect from the ozonolysis part. So study, dear all, very important reaction. Study what is ozonolysis, how to write the how to do the ozonolysis, and also how to do the backward. Okay. So this is about alkyne part. Clear? Okay, so this is about the complete alkyne part in this topic. So these are the most important area from alkanes and alkenes. Clear all of you? So alkynes, and I told you this chapter is for alkane, alkene, alkyne and aromatic compound. Alkane and alkene, practice this question again and may clarify, and all the reaction to write and practice it. Okay, organic reaction, write and practice it. Hope it's clear. The alkane and alkene part. Alkyne and benzene compound we can discuss in the next session. Thank you all.